Hello, I'm Kechang. I will introduce ViscoCam, a smartphone-based drink viscosity control assistant for dysphagia patients. Swallowing requires the coordination of up to 26 muscles, and the contraction of those muscles is tailored to liquid property. Any problems in this process may cause dysphagia. This disease is common in the senior population. 30% to 40% of people over 65 years old can be affected by dysphagia. Dysphagia can also appear in some prematurely born babies. Dysphagia patients cannot directly consume liquid like water because water flows too fast and it may enter lungs and cause respiratory infections. To reduce risk, diet modification is usually used. By adding artificial thickener, the liquid can be thickened so it will take more time to travel through the throat, and the patient can achieve timely airway closure or have better muscular control. The daily life liquid intake should be maintained at a certain viscosity level to ensure safety depending on each patient's condition. This level is usually suggested by speech and language therapists. So, a method is needed to measure the liquid viscosity in daily life setting to help dysphagia patients maintain a suitable liquid thickness level. Let's have a look at existing methods. Viscosity can be measured accurately. The National Dysphagia Diet Standard has classified liquid into 4 levels based on the viscosity ranges, but measuring viscosity accurately requires expensive lab machines like ViscoCam or rheometer. These machines are very difficult to obtain in daily life. There are some approximate methods. Some standards are based on visual observation. For example, liquid is classified by observing the liquid movement in a spoon. This method is easy to perform but not accurate. The healthcare community has proposed some objective methods. Here are 2 examples. The liquid flow test measures how fast the liquid flows out of a standardized syringe in 10 seconds. Liquid with higher viscosity will have more liquid remained. Line spread test approximates the viscosity with the distance fluid has spread over on the horizontal surface in 1 minute. Because the liquid with higher viscosity will spread slower, so the distance is smaller. These methods are more economical than lab machines, but there are still some limitations. They still require special apparatus and carefully controlling the timing. They may pollute the liquid because of the direct contact. Can there be a new objective method that is clean, suitable for use in daily life? We present ViscoCam. It can perform the viscosity measurement with only a smartphone. Just place it on top of the plastic cup containing the liquid to be tested, then just shake it to start the measurement. It does not pollute the liquid, has lower hardware requirement, and is simple to operate in daily life. The property related to liquid viscosity that we use is liquid sloshing. When a person walks while holding a cup of coffee, the liquid center of gravity moves. The liquid may then move in one direction, and we can see the increase and decrease of the liquid height on one side. Sloshing will stop because of the liquid internal friction. In this video, we see that liquid height will gradually decrease, and the rate of decrease can be associated with liquid viscosity. Thicker liquid takes less time to stabilize than thin liquid. By sensing the sloshing wave amplitude and obtain its weakening speed, we can infer the liquid viscosity. So how can we measure the liquid wave height inside a cup in real time? We use light refraction. Imagine looking at a swimming pool. You can see the view of the swimming pool bottom is distorted. This is because the light from the bottom is refracted on the surface of the liquid, and the position is shifted. From physics, we know that the degree of this shift is related to wave height. The distortion of a refraction image sequence is related to the propagation of liquid free surface waves. By observing such distortion, we can deduce the motion on the liquid free surface. To sense the liquid surface wave height changes, we use optical flow. It is a measurement of the pixel displacement among consecutive frames. So if a smartphone camera is pointing downwards through the liquid, and when the liquid is sloshing, the distortion of the view will indicate the direction and magnitude of liquid sloshing. The corresponding optical flow can represent such information. Here is the overview of the system. Video frames and optical frames are used to train a 3D convolutional neural network. During the inference, the video is trimmed so that the process of sensing the liquid Sloshing decay will not be affected by external forces. Then it will pass the neural network for feature extraction and classification. The output is the liquid viscosity level. To evaluate the performance, we follow the IDDSI standard by classifying 3 liquid types: thin, slightly thick, and mildly thick. We achieved 96% accuracy. We show that the system is robust to a wide range of testing conditions like different cup sizes, liquid depths, liquid color, and different users. ViscoCam is a drink viscosity control assistant for dysphagia patients that only require a smartphone. It is clean, convenient to use in daily life.